Hi, welcome one and all in laser world of Photonics, India. I welcome you all. And in Photonics Exchange, this and podcast partner is Laserman. And with this, our special guest is with us, Dr. Anusha Epparla, scientist in Central Manufacturing Technology Institute and from Bengaluru.
Yes.
Right, great. Welcome, ma'am.
Thank you.
My first question to you is, could you explain the science behind laser surface, like hardening, and how it improves the performance of critical materials like bearing steels?
So, first of all, thanks for giving this opportunity, and it's a pleasure coming here and engaging with our ongoing industry partners, where our main expertise domain is lasers. So here, this World Laser of Photonics is continuing its innovation platform, and it's coming here in Bangalore. It's a great opportunity for us to meet our industry partners also. So coming to your question, the laser surface hardening is not much a rocket science. It's a basic metallurgy. So laser surface hardening is it's a heat treatment process where transformation from critical oxidation temperature it will takes place, and because of the surrounding material, whatever, it's a localized process, localized heat treatment process, and because of the very high heat input of the laser beam and interacting with the steel or whatever the material that you choose, and because of the surrounding bulk material acting as a coolant for that, and that will result in self-quenching of the material. So, and austenization, and because of this high heat input, that will result in higher cooling rates. So that will leads to a uniform martensitic microstructure that is very much critical for various applications. So this will definitely, it will improve the mechanical properties by this laser surface hardening treatment.
Okay.
And we can achieve better mechanical properties when compared to conventional way of manufacturing methods. And coming to the bearing steels, till now whatever the process or conventional manufacturing methods are like heat treatment methods.
Right.
So we cannot do localized heat treatment. Suppose if you are taking very small tapered roller bearing component, so if you are doing heat treatment on that, there will be a lot of residual stresses in the, and there will be a tensile residual stress, and there will be a distortion, dimensional variations are very high.
Right.
So to avoid that, this laser surface treatment will better improve this, especially for this critical thin section components.
Okay.
So especially for bearing steels, we have already did some research on that, and we have improved the life almost 5 to 10 times when compared to conventional way of methodologies.
Okay. Wonderful. My next question is, like, your research highlights is a role of like cephalization and that to pre-treatment,
Yeah.
right? How does the process improve, especially like microstructure and even hardness and even wear resistance of materials?
Yeah. So that's a good question. Spheroidization, it's not a new process. It's a very old process which
Okay.
is used in the any types of high carbon bearing steels or high carbon alloy steels. Why it is used is generally to inculcate carbides into our material that will improve our wear performance.
Okay.
So whatever the spheroidization treatment that we are already doing, so if we are inculcating in our laser surface treatment process,
Okay.
that will give you a better improvement in properties.
Exactly.
So how it will work is in terms of science or metallurgy, this spheroidization treatment will give you in terms of globular carbides or nanocarbides within this martensite microstructure. So along with hardness, you will be getting better fatigue resistance also. That will improve the life of your components.
Okay.
So this spheroidization treatment is a complementary, like whatever the existing process, if you inculcate this spheroidization process, we will get better, more mechanical properties when compared to the conventional techniques. Okay. So spheroidization is basically used in the bearing steel only, whatever the tapered roller bearing components that I am mentioning you, this spheroidization is a conventional way of process.
Right.
So in our research also, in the recent publications, we did spheroidization with laser surface treatment.
Okay.
And along with the conventional treatment, that is drastically improving the properties when compared to the conventional treatment.
Even like there are a lot of opportunities are also in this.
Yes. Yeah.
Exactly. Right. Why do you see the most impactful applications of laser hardening, and like in areas like manufacturing, your predictive maintenance, and even heavy engineering also.
Okay.
Will you please focus?
I think there is a big list for this question,
Exactly.
definitely. But I'll concise to the recent applications what we have
Yeah.
developed. So the laser surface treatment we have developed recently onto the gear manufacturing applications.
Okay, gear manufacturing.
manufacturing.
Right.
Definitely, if you want to heat treat or improve the properties of the gear profile, whatever using in the conventionally,
Yes.
that gear profile, it will be very thin, right?
Huh.
So maintaining the heat input for that thin section components is very complex. So we can apply laser surface treatment process. Along with that, we can also do laser cladding process. Like we can deposit the extraneous material onto the existing surface, so that that extraneous material can be tungsten carbide or any type of carbide elements, such that it will further improve the fatigue resistance of the materials.
Okay.
So this is one of the gear property. Gear is one of the application, and as I already mentioned you in the previous things, bearing steel is one of the application.
Okay.
And we can further what we have studied is we can improve the automotive sector widely.
Yes.
That
Exactly.
is crankshafts, camshafts,
Yes.
normal shafts, whatever used in automobile sector.
Mhm.
These can be drastically, we can localizedly, we can heat input the process.
Okay.
See, suppose in automotive sector, suppose if you see in your car only, if some of the component has been damaged,
Yes.
you don't need to replace every part. It's a costly part, right?
It's a costly part.
So just to take the part, and where that wear and tear has happened extensively, there only you do the process, this heat treatment process. So it's a cheap process, like you are not buying the whole product. It's a cost effective process. So that is making this laser treatment very attractive.
Very attractive.
When compared to conventional way of things.
Great.
So, and other applications are like mainly in aerospace also. In high temperature applications, this laser surface treatment is drastically improving.
Okay.
It's a secondary process. Like whatever the conventionally you do, this is adding as a secondary process.
Part. Right.
So that will. So many aerospace sectors and defense sectors are using this laser surface heat treatment process in various critical components.
Great. Could you share some examples regarding, like, with laser surface, any modification or some technology that has been already made for a measurable difference, right, in industrial performance? Will you please?
So I can better give you example on this bearings only. So we have got a project from some company, I cannot tell you that. So they have given certain examples, like they have given very thin section components to almost thick sections bearings. So practically till now in India we are using only conventional heat treatment process only. So now what we have proven is, like, with the laser heat treatment process, these bearings life has been improved drastically. Along with that, we are also giving metallurgically good bonding when compared to other conventional techniques. And other than bearing steels, we have also worked on various critical aerospace components, like improving the life of heat exchangers and crankshafts in automotive sectors, and many of the critical components of the various engine motors. So all these sectors have been benefited for this laser surface hardening applications.
There are certain challenges are also, like, what are the biggest challenges in moving laser surface treatment from lab to large industrial adoption, right? And how can research institution, rather industry, collaborate to overcome them?
Yeah, that's a very good question. Actually, if you want to, suppose you take, this is a big component that you want to heat treat.
Yeah, please.
So this is a very big component.
Okay.
If you want to do conventionally, you can directly keep in furnace.
Okay.
That is possible.
Okay.
But whereas in lasers, because it's a localized process, doing this much big component, it will take a lot of time. And whatever the laser spots that you are using are also very small, because you want very high heat input in the localized process.
Okay.
So you need to do much overlaps when you want to scan larger area.
Okay.
So when you are doing overlaps, there will be a tempering effects, like softening problems will be there. So to avoid that softening problems, we need to do a lot of process optimization, and we need to do a lot of in situ control. Like wherever the temperature is dropping, you need to control your process parameters.
Okay.
So that in situ online monitoring has to be adopted. such that you can easily scalable your laser surface treatment process.
That can
As
be
you,
process. This is one process, right?
yeah.
Through this.
So that can be definitely done.
Okay.
When you are doing in situ online monitoring, like we can do in situ online monitoring by various techniques, by using thermal based cameras or normal vision cameras. We can implement those cameras and know your process, know the physics behind the process, where the metallurgy is changing, that you have to exactly know the process and modify your process parameters such that you are maintaining the temperature uniformly throughout the process, and there won't be any dimensional variations. So it will be similar, like you are not like because of larger area I am unable to do. You can definitely do, but you have to build confidence in your physics. So that will definitely scale up your laser surface treatment process. So mainly this can be definitely done by bridging the gap between academia and industry. Definitely academia is required for
And
knowing
industry.
the metallurgical point of view, and if you want to simulate your product, definitely your metallurgy process simulation, academia is definitely required to know your metallurgical insights. And industry, why industry is required is to know your real use cases,
Rather practical implications.
practical use cases.
Yeah.
So I definitely don't know where my treatment is required. Industry should tell me where actually you are facing your problem.
Exactly.
So more wear and tear is happening in my component. So I can provide, academia can provide you some solutions. So this gap has to be definitely to be resolved.
This must be fulfilled, yeah.
And government also should come up with some new initiatives.
Yes.
Like industry, academia collaborations.
Yeah.
And the government also has to support this funding
Government
mechanism.
has to support. That's true.
Mainly funding mechanism has to be improvised.
Yeah, exactly. Because there are even a lot of opportunities over here where like this, I mean, this bridge can get fulfilled.
Yes,
right?
yes.
Well, my next question is, what emerging trends and material processing excite you the most?
Okay.
And how do you see regarding shaping industries over next decade?
Yeah, definitely. Almost I'm working into the lasers from almost 12 years.
Yeah.
So laser is definitely, we cannot replace this with any other process.
No, nothing.
Any other non-conventional manufacturing process. Why? Because whatever the heat input that you are giving is very controllable manner. Whereas in other, whatever the process that you do, this is not a controlled mechanics cannot be done. Whereas in conventional methods, whereas in this you can do controllable mechanism can be adopted. So my excitation is for additive manufacturing.
Okay.
That is like adding whatever the deposition of the extraneous material. Suppose there is a cheap steel, you want to improve its standard.
Okay.
So no need to replace that whole steel.
Okay.
You can develop some new alloying materials which can be high temperature and corrosion resistant, that you can deposit onto this cheap steel.
Okay, that can be deposited
onto this steel.
Okay.
So that is known as additive laser cladding process. Like you are doing bonding of some two different materials.
Okay.
So that can be done. Means indirectly you are not saying that is a cheap steel. That is a now it has become very high quality steel.
But still that can be
accommodated. So it's like improving the mechanical properties of normal steels also can be done by using this additive manufacturing process.
True.
And why there are so many processes are available in the laser techniques only, like laser cladding, alloying, laser heat treatment, softening, and additive manufacturing is a hot topic for this.
That's
so true. Additive manufacturing, there is also a certain limitations, like there is only only small components we can build up. So that we have overcome in our organization, that is in CMTI. Recently we have launched and developed a large scale additive manufacturing machine that is indigenously developed. So no need to depend on our import things, where we cannot do any replacement on our import things. We cannot touch our machine also. Whereas in our indigenous machine, we can do each and every repair, and whatever you want to implement, like new materials, there is no material restriction also. So now there is no limitation of doing small components. You can print very large components also with the existing indigenous developed AM machines.
That's great. Well, let's congratulate you, Dr. Anusha. Like you have honored woman professional achiever.
Yes.
By Science of Making publication. That's really great.
Thank you.
Wonderful. So whether you have any message for any young woman and engineers who like aspiring for their mark in the view of like technologies, laser technologies and advanced manufacturing. Your message.
Yeah.
Please.
So first of all, I will start with like these awards are mainly between why these awards are mainly because of we are bridging the gaps between industrial use cases and
Exactly.
academic solutions.
Exactly.
So basically, we are collaborating with the academic institutions. So that is majorly helping in driving our innovation case studies.
Exactly.
So definitely if you are sitting in our own place and doing novel things, definitely it won't be possible. Definitely collaborations with all the academic institutions where their potential we have to know. So that is helping us in driving new innovations, and
because you could able to know like what is actually the real want,
yes,
what is actually the real need,
yes,
right?
Yes.
And
My message to the young engineers or young researchers is like,
yes,
you need to be very perseverance, that curiosity and innovative thinking has to be there.
Exactly.
So you have to be very curious in knowing new things.
New things. So and that sort of curiosity must be there.
That curiosity must be there.
Exactly.
So definitely that you have to imbibe or inculcate from childhood only.
Yeah.
Suddenly we cannot get instantly in that you have to inculcate from the childhood only, like knowing no things. Why is the question mark? Definitely you have to ask, and it has to be resolved, and you have to know the answers also.
True.
So that environment has to be created, first thing. Yes. And one more thing is, you should not hesitate in going into multidisciplinary fields. Okay. Suppose I am mechanical engineer, I should not be confined to I am a mechanical engineer, I don't want to go into electrical, I don't want to go into physics. So if you are in laser field specifically, from laser, if you see, it will start from physics, metallurgy, mechanical and simulation, and if you want to do any in situ online monitoring, you need to know coding also. This will be a wonderful message and learning, especially for the young you scientists. You have to be in multidisciplinary fields. Exactly. You need to be a multidisciplinary fields, so that there are opportunities in various fields. Why to stick to any one? Yes. Right. No, great. Wonderful learning for young scientists. Yes. Great. And lastly, just wanted to say like we are basically publishing this Laser India magazine, right? In that we are publishing like all the news articles, the advertisement, even the machine repairing regarding the consultants to the business firms, right? Even the research, the publications for the new, academia as well as industry people, right? So even events also we are sponsoring and all. So any message for Laser India magazine? First of all, before 12 years when I was entering into the laser field, I was definitely not knowing whom I have to contact to know the actual mechanism or actual physics. Exactly. So definitely we won't be knowing A to Z, right? So we should know the basics, we should know the exact use cases, final applications. Right. So I was lingering like where I have to contact. There is no particular platform. Exactly. So this magazine is definitely helping for all the innovators from academia, industry, researchers. Yes. It's a unique platform. Like you can know all the innovations, and I already published 2 in this Laser India magazine. Oh, great. My recent studies. Yeah. So it's like some common platform where you will get all the things. Exactly. So that will definitely, I would suggest like more innovations, more people has to be creative, and they publish their results in that, such that people will be educated and it will transfer the knowledge to the young researchers also. It is a good initiative and good platform for, especially for laser physics. Dr. Anusha, it is really wonderful like converse with you, and it was a wonderful interaction. Like even the audience also, the scientists, the young scientists, they also got a lot of knowledge from you, as you are having a lot of experience in this field. Sincere thanks to you for appearing in this session. Thank you very much. Thank you so much. Thank you.